in 1990 for a mere $10,252 2024 US dollars, or about $4,250 $1990, you could have purchased this KRELL KBL stereo line preamplifier. Now this is a two-piece unit. There is the power supply portion here, and then of course the preamplifier section here. KRELL only provided a few specifications. One of them was that it had a frequency response from 1 Hertz to 250 kilohertz, without saying what the plus or minus dB was on that, and that it had an SNR of 100 dB. And that's about all the specifications other than the weight that I could find on this particular unit. Now KRELL is a very high-end audio brand, and I'm fortunate that I was able to get this from my good buddy Richard to test. And so I'll do the standard kind of review I do. We'll look at the controls in the front, we'll look around back, see what's going on there. I'll remove the cover, we'll kind of see what's going on inside. And then of course there will be a plethora of data. And finally I will tell you how it was to listen to this and just use it in general.
Here's a close-up view of the KRELL KBL Preamplifier. This guy on the top is the power supply for it, and it normally wouldn't sit on top. I just have it there so you can kind of just see what it looks like. Our input selector is here on the far left, and it selects between 2 balanced inputs or 4 unbalanced inputs. You can monitor the S1 unbalanced input or the B2 balanced input, and that would be like your tape monitor loop. You also have a gain switch right here, and its normal gain is 9 dB. If you put it into the high gain mode, it has 15 dB of gain and the LED turns red. You can also invert the phase of the outputs by 180 degrees. The symmetry switch would be your balance switch, and then we have our volume switch right here. Now the KBL can be operated as a dual mono configuration if you purchased another one, in which case the symmetry control affects something a little bit different than the normal balance. Coming around back, here we have our 2 balanced inputs, and then we have our 4 unbalanced inputs here. They're gold plated. And our tape outs are right here for the monitor circuit, and here is the unbalanced preamp output and the balanced preamp output. We have our DC in from the power supply here, and then if you had a second KBL preamp, you could run it with a cable plugged into here. This is the inside of the KBL, and there's a lot going on. It is a direct coupled Class A design, and it's meant to be left on all the time except for extended periods where you were not going to be there. There was no on-off switch on the front, if you noted, and I believe the power supply does have a on-off switch, but there are no on-off switches because it's supposed to be left on all the time for whatever reason. And it just kind of shows how things were built. They have a lot going on there, and it looks like they use a lot of good components. Here is the KBL's THD SNR response at 1 kilohertz with a 0 dBV or 1 volt RMS signal going into the unbalanced S1 input. And there is no specification other than the SNR was supposed to be 100 dB, and we're pretty close to that. And I don't know whether that 100 dB was for the balanced or the unbalanced inputs. I've also set the volume control so that I could get about 0 dB of gain. We're pretty close to that. And I should point out we're in the normal gain setting for the preamplifier. It does have a high gain position, but this is just for the normal gain. And I should also point out that the volume control is almost at a maximum in order to get it to have 0 dB of gain. The THD looks pretty good. The left channel is not as good as the right channel, and if I go ahead and remove the left channel, you can see that the harmonics of the right channel are much lower than the harmonics for the left channel, at least the second and third harmonics. Let me bring those back up. Once again, there is no specification other than the 100 dB SNR, and we're almost there. As far as the other things, our THD plus noise is greater for the left channel, and that's because of the high level of the first or the even harmonic. And other than that, it looks pretty darn good. Once again, we're looking at the THD SNR plot at 1 kilohertz for the unbalanced inputs and outputs. And I just wanted to compare it to the balanced input case. And actually, when you look at the numbers with the volume control set for 0 dB gain and a 0 dBV input signal, and I should point out that the KRELL is in the normal gain state or the low gain state. There's really not a lot of difference between the two. I mean, the THD for the left channel is a little bit lower in the balanced, and for the right channel it's a little bit lower, but they're real small numbers. THD plus noise is a bit better with the balanced input, and you would expect that. THD plus noise is maybe a little bit better with the balanced inputs, and the SNRs are actually a bit worse, which is at least for the left channel with the balanced input, it's maybe almost 4 dB worse for the left channel with the balance compared to the unbalanced, and the right channel, the SNRs, are only about a dB worse. So that's kind of what it looks like. And now we'll look at the noise level of the balanced input. Here is a plot showing the system noise. In this case, I've terminated the S2 inputs, and we're looking at that unbalanced input. And it is down about 100 and, we'll call it 15 dBV down. This is really pretty quiet from all of the preamps that I've looked at. Here is the KBL system noise level, and this is using the balanced input, which is terminated into shorts. And if you compare it to the unbalanced input under the same conditions, it's a little quieter, not really very much, just there's a little spike over here with the unbalanced input, but overall the levels seem to be pretty much the same. I've adjusted the KBL's volume control to give me the maximum gain, which is about 2.4 dBs. That's about the most gain we're going to get out of it with the setting for the normal gain position for the gain switch. There's a high gain position, and we'll look at that in just a little bit. You can see that our distortion is still pretty good, and the THD plus noise looks about the same. The SNRs went up a little bit, maybe at least for the right channel, when we set the volume control to maximum. Once again, here's our standard THD SNR plot at 1 kilohertz with a minus 10 dBV signal going into the S1 unbalanced input. And the reason for that is that the gain is now set for the high gain position. I did not change the setting of the volume control, so in the normal gain position, the volume control was set so that we have 0 dB. Now we have about 6 dB of gain. So that's kind of how much gain the high gain is giving us. Also, you can see that our SNRs decreased. The THD, at least for the left channel, is not as good as the right channel, and the THD plus noise is also not as good as it was in the normal gain position. Also, I have the input set for minus 10 dBV because if I increase that signal level up towards 0 dBV, I start getting a lot of distortion. So I figure that you're going to be having a smaller signal going into the unit when you would use the high gain position. And this is kind of what happened with this KBL. And if I lowered the signal level from minus 10 dBV to minus 20 dBV, our distortion does get better. However, the THD plus noise is staying about the same, and the SNRs are still about the same. Right now, we're looking at the THD SNR plot at 1 kilohertz, of course, with the KRELL KBL plugged in, and it's been about 45 seconds since I powered it on, and I want to do an experiment where we see if things change after it has been on for an hour. Because this particular preamp has a separate power supply, and so everything is always on with it. You can see our THD is about 0.06% for left channel, about 0.003% for the right channel. SNRs are about 98 or 95 dB. And our THD plus noise for the left channel is worse than the right channel. And if I get rid of the left channel, you'll see that the right channel harmonics are much lower. And we'll come back to this thing in an hour. I won't have it playing for an hour, but I'll go ahead and turn it back on. I should point out that I have set the volume control for 0 dB of gain, and I'm using the balanced inputs and outputs. That would be the balanced one. We've got a 0 dBV signal going into the unit. The KRELL KBL has been on for over an hour, and I don't really see any drastic changes at all. I mean, the left channel THD went from 0.0538 to 0.03439. THD plus noise, well, it's a little bit better. It went from minus 90.83 to minus 91.83, and we went from minus 65.37 dB when it was instantly on to minus almost 2 dB better, minus 67.98. Gain didn't change hardly at all, and the SNRs are a little bit worse for the left channel. Now, there could be something going on with the left channel as well, but for the most part, using it right away doesn't seem to be a problem with this particular preamplifier. So I don't know why it would be something that would always need to be on. Right now we're looking at our standard THD SNR plot at 1 kilohertz using the balanced inputs and outputs with a 0 dBV signal going in. The preamp is set for the normal gain state, or the low gain state as they call it. And I kind of wanted to show what happens as I increase the volume level to see what the most amount of gain that we can get. Now, apparently with this particular KBL, our left channel has some issues. Once again, if I turn off the left channel, you can see how nice the right channel looks, but the left channel is different looking for sure. And you can see we're up here at 0.1% THD or thereabouts, gains at 10 dB. I'm going to go ahead and turn the left channel off, and we'll just see how much gain we could get out of the right channel before the THD gets all wacko. So right now I've got the volume control set for maximum, and actually the left channel didn't get much worse, so we're at about what we'll call it 14.5 dB of gain we can get out of this guy using the balanced inputs and outputs. The right channel still looks really good. The SNR looks really good. Even the SNR for the left channel looks really good. Let's turn that on. But you can see it's got some issues there with that, the first harmonic, the even harmonic there. So that's kind of what things are looking like with the balanced input and output and the volume control set to max. Right now we're looking at the KBL's frequency response from 10 Hertz to 50 kilohertz. I'm using the unbalanced inputs. They happen to be the S1 selection in this case. We are putting in a 1 volt RMS signal into those inputs, and the volume control was adjusted for 0 dB gain, and we are in the normal gain state. Now, the only specification that was provided by KRELL was its frequency response was from 1 Hertz to 250 kilohertz. They didn't say what the amount of variation was, but you can see that we're looking pretty good. I mean, at 50 kilohertz, we're only down 1/10 of a dB. That's excellent. And at 10 Hertz, we're maybe up 1/2 a dB for the left channel and down a little bit for the right channel, maybe a little over 1/10 of a dB. So, you know, at 20 Hertz, it would be up 0.3 of a dB and only down maybe 0.05 dB, something like that. So overall, the frequency response looks really good. The channels are fairly well balanced, except when you get in this low frequency range. There is quite a bit of variation, but at worst case, it's under 0.5 dB. Right now, we're looking at the KBL's frequency response using the balanced 1 input to the balanced output, and in this case the frequency span is from 10 Hertz to 50 kilohertz as we did it with the unbalanced case, and we have a 0 dBV or 1 volt RMS signal going in. There was no specification for the frequency response. It is worse than the unbalanced case. We're at 0.7 of a dB, at a positive 0.7 of a dB gain here, and then at 20 Hertz we're within 0.4 of a dB, and the two channels are not balanced, but it has a whole different look with the balanced inputs. I think the unbalanced input might be a little bit better. At least the right channel is definitely better here at the low part of the band if you compare the two. At the high end of the band, they both kind of follow about the same. There is more of a channel separation, although it's less than 0.05 dB, I would say, at least at the low end. At the high end, it's actually better with the balanced case than the unbalanced case as far as the channel separation. In case you were wondering about the KBL's Crosstalk, here it is from 20 Hertz to 20 kilohertz. I'm doing it with two different levels going into the KBL, and we're using the unbalanced S1 input. This level right here, this is your left and right channel, and this is the left to right crosstalk with a 0 dBV signal going in, or 1 volt RMS. And then this other curve here, or curves actually, is with a -6 dBV or a 500 millivolt signal going in. So we have more signal going in, and our crosstalk is a bit better. I mean, we've got almost, we'll say, 85 dB best case for the lower signal level. And when we put in the 0 dBV signal, we're at about 66, 67 dB of crosstalk. Of course, when we come down over to 20 kilohertz, they both kind of level off at about 42 dB, which is actually decent from most of the crosstalks that I've measured at 20 kilohertz. Right now, we're going to look at the input to input isolation of the KBL. The frequency range is 20 hertz to 20 kilohertz, and I've got a 0 dBV signal going in. I'm only going to show the right channel, and it's shown here across the top here at 0 dBV. Now, the input to input isolation is going to be between the S1 and S2 inputs. In this case, the S1 input is this guy right here in red. That is our reference trace. And the S2 input is terminated into shorts. I'm going to go ahead and switch over to the S2 input, and the amount of isolation between the two inputs will be seen down here. So let's see what happens. Okay, so it looks like we have about 75, 80 dB of isolation. Remember, we started at 0, and the leakage over to the other's right channel for the S2 input is what we're seeing. So we're down, we'll call it 80 dB of isolation between the S1 and S2 inputs. Right now we're looking at the difference in phase between the unbalanced left and right outputs of the KBL. This is at 1 kilohertz, and basically there is no difference in phase. If we change the frequency to 20 kilohertz, there is a small amount of phase difference between the left and right channels, but not very much. And at 100 hertz, there is no difference in phase between the left and right unbalanced outputs. Here is the phase difference between the input going to the left channel and the unbalanced output of the left channel, and that unbalanced output is going into a 47 k ohm load. And if we move the frequency to 1 kilohertz, we're seeing very little difference in phase between the input to the output of the KBL. And at 20 kilohertz, we do see a little bit of phase. I'd imagine this is probably less than 5 degrees here at 20 kilohertz between the input to the unbalanced output. Here is a rise time shot, and our input rise time is 48 nanoseconds, and this is one of the faster rise times that I've seen at 522 nanoseconds. Usually they're in 2, 3, 4, or 5 microsecond range, so this is a bit faster. And this is once again looking at the unbalanced left input to the unbalanced left output of the KBL. At 20 kilohertz, we see very little change from the 1 kilohertz rise time, and it's still looking pretty good. The KBL doesn't list any specifications for phase or rise time.
This particular KBL performed pretty darn good. I would say for a couple of its measurements, it's one of the top preamplifiers that I've measured. Now, the left channel looked like it had a little issue with the first harmonic or the even harmonic being higher than the right channels, and that of course affected its THD SNR overall. But even with that considered, it did pretty good. Now the balanced inputs measured a little bit better than the unbalanced inputs, but not a lot different really, including the system noise. It does have a very low system noise level. Either way, balanced or unbalanced inputs. And there's something going on with that left channel, but it wasn't anything that I was able to hear. You could see it in the measurements, but it's probably under conditions where you've got a lot of gain from the volume control, and you've got a larger signal by that, greater than 0 dBV going into it, which probably wouldn't happen all that often. But even with that considered, it still measured pretty good, I thought, overall. That's kind of why it's got the Corvette on top. But it's an expensive preamplifier. I thought the build quality looked pretty good. And once again, it's a unit that I got from my buddy, and it kind of just gives you an idea when you go out and purchase something. I mean, you can listen to it, and we're not going to hear what we measured with this particular unit. The distortion on the left channel is a little bit higher, but I think even at worst case it may have been a couple tenths of a percent, maybe 0.5% worst case, and most likely you wouldn't even hear that under the conditions where it was measured. So overall, it's a very clean preamplifier. Now, I'm not a fan of having a separate power supply for the unit. There's a couple other things that I've reviewed that do have a separate power supply, and I don't really see a big advantage. Now, KRELL doesn't provide an on-off switch for either unit. They want it always to be on. I really don't know why. You saw the test data where I measured it within a minute of being turned on from a cold start, and then after it'd been on for an hour. Really insignificant difference. So I don't know why you need to keep it on all the time. It doesn't draw a lot of current, maybe 700 milliamps from what I measured when it's plugged in, but it does get warm after being on. By warm I mean it's 100 degrees F after it had been on for a while. And the preamp, it does run just a little bit warm. I mean, you know that it's on, but it's not going to, probably wouldn't even melt the candle, possibly, but I wasn't going to try that. But you can tell it's warmer than, say, my Carver C1 preamplifier, which stays pretty much cool. So, that is what it is. I think it has a decent look to it. The frequency response, it did have something going on there, at 10 hertz, and even at 20 kilohertz, it's still within plus or minus half a dB. The channel balance between the left and right channels wasn't, as stellar at 20 hertz, as it was when you went up to, say, 20 kilohertz. But overall, I thought, it performed rather well. Now, as far as the sound of this unit, I hooked it up to my Carver M400A Cube amplifier, and I also used just my normal audio source that I use and listen to the variety of music that I listen to. And the speakers were the Wilson Watt 3 Puppy 2 loudspeakers. Listening to a variety of music, it sounded just fine. It's very clean and quiet. I mean, there's nothing extra going on with it. Just did what you would want a preamplifier to do. Of course, it has no tone controls. I like having tone controls, ideally with a tone bypass, but purists want to have the signal going as straight through as possible. The controls were quiet, adjusting the volume control. I didn't play with the symmetry control at all. There was really no reason to. The balance was very, very good on these. So overall it just sounded fine. So I couldn't resist doing an A/B test with my venerable Carver C1 preamplifier, and I set it up and measured the levels, and of course really no difference at all between the two. Switching them immediately, several different tracks of music, and I couldn't hear really any difference between them. That is what it is. So other than that, if you want a nice preamp, it's got a good look, it's got the KRELL name to it, and you have the ability to have it measured or listen to it, and there's no problems. It's a nice piece of gear. I appreciate you watching the video, and if you like the video, give me a thumbs up. If you haven't subscribed to the channel, of course, please subscribe to the channel. And I like hearing your comments and questions, so leave them in the appropriate spot. And until next time, have a great day or night.